silent language woven through the fabric of the cosmos holds no true accidents, only events so astronomically improbable that they defy the simple mathematics of chance. Our universe is a vast machine of predictable, elliptical paths, yet within this ordered system, sudden anomalies, cosmic coincidences, can shatter our most trusted models. Right now, in our own local stellar neighborhood, 3 celestial visitors, each one a profound mystery, a traveler from the deep void, are converging in the night sky. 2 objects are certified interstellar travelers, intruders from an alien star system, and the third is a comet of extraordinary beauty. Soon, they will align to form a perfect, fleeting cosmic axis. Based on what we know of statistics, this could imply the universe is sending us a deliberate signal we haven't yet learned how to read, rather than being a mere statistical fluke born from the immense probability space of the solar system. This is Axiox. To understand the sheer improbability of the current alignment, we must first appreciate the singular nature of the objects involved. These are not indigenous residents of our solar system. They are interstellar interlopers. For over 400 years, since Johannes Kepler codified the laws of planetary motion, our solar system has been defined by the ellipse. Every planet, asteroid, and short-period comet follows an elliptical path, a closed loop around the sun, gravitationally bound forever. Interstellar objects defy this fundamental rule. Their motion is defined not by a closed ellipse, but by a mathematically distinct hyperbolic trajectory. The key mathematical difference lies in the orbital eccentricity. For any object gravitationally bound to the sun, for an interstellar object, the eccentricity must be. This value signifies that the object's velocity is so high, often tens of thousands of kilometers per hour greater than the solar escape velocity, that it can never be captured. It approaches the sun, changes direction slightly due to gravity, and then slingshots back out into the galaxy, never to return. This is the unmistakable mark of a true visitor. The trajectory is so energetic that its specific orbital energy is positive, a stark contrast to the negative energy of gravitationally bound planets. This positive energy is quantified by its hyperbolic excess velocity, in 50t, the residual speed the object would settle into once it is infinitely far from the sun's gravitational influence. For example, 2I Borisov's eccentricity was measured at a staggering E, approx. 3.36, dwarfing even the E, approx. 1.2 of 1I Oumuamua, illustrating the sheer kinetic energy carried by these galactic nomads. The discovery of the first 2 objects confirmed to possess these hyperbolic paths, 1I Oumuamua in 2017 and 2I Borisov in 2019, confirmed what was previously only theory, that the galaxy is filled with ejected planetesimals, the cosmic detritus of other star systems. Estimates now suggest that thousands of these interstellar objects pass inside the orbit of Neptune every day, though their detection only became possible with modern, high-cadence sky surveys like Pan-STARRS and the eventual Vera C. Rubin Observatory. The very idea of a celestial alignment carries immense weight, rooted deeply in human history and philosophy. While modern science views these events as geometric conjunctions, mere lines of sight, ancient cultures saw them as omens, warnings, and cosmic blueprints. For the Babylonians, meticulous record keepers from as far back as 1800 BC, conjunctions were recorded not for pleasure, but as celestial omens sent to the king to warn of war or catastrophe. Their astronomical success was directly tied to this social value. The ability to predict the movements of the 7 planets was a matter of state security. The Mayans intricately wove planetary cycles, particularly those of Venus, into their highly complex calendar systems, believing the alignments influenced terrestrial events. In medieval Europe, the great conjunctions of Saturn and Jupiter, occurring roughly every 20 years, were seen as harbingers of profound change, periods of social upheaval, or the birth of new religious or political eras. More dramatically, the devastating plague of 1345 was tragically linked by astrologers to a specific Saturn-Jupiter conjunction, fueling widespread hysteria and despair across the continent. The alignment of a comet, a historically rare and often terrifying spectacle, with other celestial bodies would, in any previous era, be seen as an event of world-altering significance. But this is not merely a planetary parade. It is an alignment involving 3 bodies on unbound, alien trajectories. The rarity here is not merely geometric, it is fundamentally existential. The current event, the convergence of 3I Atlas, C 2025 V1 Borisov, and C 2025 K1 Atlas, along the same line of sight in the constellation Virgo, forces us to look beyond historical precedent and grapple with raw probability. When astronomers discuss the chance of a 2-body alignment, a conjunction, involving bound orbits, the mathematics, while complex, is solvable. The current alignment, however, involves 3 objects, 2 of which follow open-ended hyperbolic paths, meaning their trajectories are non-repeating. The complexity jumps to the mathematically chaotic 3-body problem. The 3-body problem, defined by the Newtonian equations of motion for 3 gravitationally interacting masses, has no general closed-form solution. It is inherently chaotic, making the simultaneous calculation of 3 specific, non-repeating trajectories that result in a collinear alignment, as viewed from a 4th moving point, Earth, a statistical nightmare. While the vastness of space suggests that given infinite time, any event is possible, the instantaneous, near-perfect alignment of 3 such unique bodies, 2 unbound interlopers, and 1 major comet within the narrow 48-hour window between November 6th and 8th defies easy statistical dismissal. Probabilistic models, particularly those applied to interstellar object traits, highlight the extremity. The retrograde trajectory of the new interloper, 3I Atlas, is aligned to within 5 degrees of the ecliptic plane of the solar system, an alignment calculated to have a likelihood of only 2 for a randomly oriented object. When you compound this low probability geometric constraint with the extreme rarity of the objects themselves, the calculated probability of the full triple axis plummets toward negligible levels. Furthermore, the inbound direction of 3I Atlas is coincident with the location of the famous WOW signal to within 9 degrees. This specific calculated positional overlap, based on what we know of astronomical coordinates, is an extreme convergence of anomalies. This is why the event is categorized as an axis of the void. It is a direct coincidence that science cannot easily categorize as mere random chance. The central mystery of the cosmic axis lies not just in the alignment itself, but in the unsettling nature of the 2 interstellar travelers that define it, 3I Atlas and C 2025 V1 Borisov. While the first 2 objects confirmed to be interstellar were initially celebrated as a conceptual breakthrough, these new visitors present a far more complex set of physical anomalies. They are not merely chunks of rock or ice ejected from foreign star systems. They are, in their current manifestation, defying the most basic expectations of interstellar matter. The standing expectation for any cold, volatile body traversing the vastness of space is that upon crossing the solar frost line, the boundary inside which solar heating is sufficient to cause the sublimation of ice, it would begin to shed material. This process generates the telltale gaseous coma and the ion tail or dust tail. This signature volatility defines the comet, which is the most common form of interstellar wanderer predicted by standard nebular theory. However, repeated photometric and spectroscopic observations of 3I Atlas have shown a peculiar, almost deliberate stubbornness. Its trajectory is unequivocally hyperbolic, with an orbital eccentricity safely above inter, placing it firmly in the category of a true galactic interloper. Yet, as it rounded the Sun, it exhibited a near-total lack of cometary activity. No measurable coma was detected even by the most sensitive instruments, and critically, there was no significant non-gravitational acceleration. It behaved like an inert asteroid of incredibly dense composition, traveling at interstellar speeds. This inertia is a profound challenge, forcing us to consider that a significant population of interstellar objects may be hyperdurable, highly processed rock, rather than the expected volatile ice. This shift in understanding dramatically changes the calculated density of rocky detritus moving through the galaxy. The concept of non-gravitational acceleration is the litmus test for volatility and a key marker for the mechanical nature of these visitors. When a comet is heated by the sun, the resulting jets of sublimated gas create a small, asymmetrical thrust on the nucleus. This thrust slightly alters the object's trajectory away from the path predicted by complex, pure gravitational models. The two objects forming the current axis, however, defy this predictable spectrum. 3I Atlas shows no non-gravitational acceleration, reinforcing its status as an inert, highly durable rock. This suggests an origin in the hot, inner region of its home star system, or a composition so tightly bound that it resisted the harsh radiation environment of the deep void for perhaps billions of years. This lack of outgassing is geometrically simple, but physically complex. It demands either that all surface volatiles were stripped before ejection, or that the object's bulk is far denser than assumed. See 2025 V1 Borisov, the second confirmed interstellar comet to bear the name, is even more perplexing. While it did exhibit some brief, faint signs of cometary activity, the measured non-gravitational acceleration was inversely proportional to what is expected. Normal outgassing pushes the object away from the sun, speeding its escape. This Borisov, however, appeared to be slightly slowing down its hyperbolic exit velocity more than expected by gravity alone. This phenomenon is termed a negative non-gravitational parameter in orbital mechanics. While rare, a negative parameter suggests that a force other than common rocket-like thrust is dominant. This could imply a high albedo, reflective surface, where radiation pressure acts as a counterintuitive brake, or perhaps a unique mechanism of anisotropic outgassing, a scenario where the jetting is primarily oriented to produce drag rather than thrust. Such contradictory behavior necessitates models that account not just for solar physics, but for alien planetary system dynamics and volatile distribution within the nucleus itself. Spectroscopy offers the only reliable window into the alien chemistry of these visitors. When analyzing the faint spectra of 3I Atlas, the readings consistently pointed to extremely refractory material, indicating elements that resist vaporization even at high temperatures. The data showed clear signatures of forsterite and wadsleyite, high-density magnesium iron silicates that form under intense thermal stress. This composition could imply that 3I Atlas is the enduring, high-pressure core of a destroyed planetesimal, or material that survived extremely close proximity to a massive star. This composition confirms its status as a geological fossil from another star system, providing the first hard evidence of non-volatile alien building blocks. The isotopic ratios of oxygen and silicon within Atlas offer a completely distinct signature, incompatible with any known solar system reservoir, further cementing its foreign origin. In stark contrast, the 2025 V1 Borisov shows clear evidence of containing exotic ices, compounds, and isotopic ratios not commonly found in our local solar system. Initial results point toward a significantly high abundance of nitrile ices, ethane, compounds that form optimally in the deepest, coldest molecular clouds, or within the highly shielded regions of a star's protoplanetary disk. Crucially, the measured deuterium to hydrogen DH ratio in its water signature is higher by a factor of 3 compared to the ratio found in terrestrial water and most solar system comets. This elevated ratio strongly suggests its birthplace was a chemically distinct stellar nursery, one where the environment favored the binding of heavy hydrogen isotopes. The contrast is a profound statement. One visitor is an extremely durable, inert, refractory rock, 3I Atlas. The other is a hyper-chilled, chemically alien snowball exhibiting bizarre dynamics. See 2025 V1 Borisov. Their alignment is a collision of two completely different galactic histories, offering a glimpse into the vast chemical diversity of the galaxy. The third body in the axis, C 2025 K1 Atlas, provides a crucial point of reference and a visually stunning spectacle. It is a long-period comet, originating from the Oort cloud, the vast, spherical shell of icy debris that envelops our solar system. Unlike its two interloper partners, C 2025 K1 Atlas is behaving exactly as classical cometary theory predicts. It is shedding material profusely, developing a spectacular golden tail. Its spectrum is rich in common solar system volatiles, with a DH ratio consistent with our own stellar nebula. This classic cometary activity confirms that our local solar system is functioning normally, making the anomalous behavior of the two hyperbolic visitors all the more pronounced. The Atlas comet acts as the control group in this cosmic experiment. The alignment, therefore, juxtaposes three specific types of cosmic travelers. 3I Atlas, the inert, refractory, high-speed hyperbolic asteroid, a geological fossil from an alien star system, defying the volatility expectation. C 2025 V1 Borisov, the active, chemically distinct, highly volatile hyperbolic comet, an icy artifact of a different cosmic cloud exhibiting negative acceleration. See 2025 K1 Atlas, the predictable, bright, volatile Oort cloud comet, a classic local resident following standard Newtonian physics. Their convergence into a single line of sight is not merely a statistical anomaly. It is a profound cosmological statement, a direct confrontation between the known chemistry and dynamics of our solar system and the alien physics of the deep void. The answer may lie in the precise geometry of the alignment itself, which is tied to the ancient map of the heavens. The alignment itself, the axis of the void, is defined by its precise location and its astronomical properties. It is not a broad, multi-day spectacle, but a tight conjunction occurring at the celestial longitude of 189.4 degrees in the constellation Virgo. This precise location is critical. Virgo, the largest constellation in the zodiac, holds profound significance in both astronomical observation and historical cosmology. Virgo is not merely a random patch of sky. It hosts the Virgo Cluster, a massive collection of galaxies that forms the central gravitational hub of our own local group. Our Milky Way galaxy, along with Andromeda, is part of the larger Virgo supercluster. The alignment of these three anomalous objects occurs directly along the line of sight toward this gravitational nexus. This geometry raises the immediate, if remote, possibility that the dynamics of the alignment are subtly influenced by the gravitational gradient of the supercluster itself. While the local influence of the Sun dominates the hyperbolic paths, the constant gravitational tug from the Virgo cluster subtly dictates the overall movement of our entire solar system through the galaxy. This could imply that the axis forms precisely in this direction, linking the immediate, local physics of the Sun to the largest known structure governing our motion. It is a sightline that connects the most ephemeral, transient bodies in our solar system, the interlopers, to the most enduring, massive structure beyond it. For a tight alignment to occur, the three bodies must momentarily share not only the same celestial longitude, but they must also share near identical celestial latitudes, meaning they must momentarily sit close to the ecliptic plane. The ecliptic is the geometric plane of Earth's orbit around the Sun, and all major planets lie very close to it. The challenge is that interstellar objects generally approach the solar system from random directions, meaning they often have trajectories steeply inclined relative to the ecliptic. 3I Atlas, the refractory interloper, has a highly retrograde orbit, yet its plane is inclined only about 5 degrees to the ecliptic. This suggests, based on dynamical models, that the object must have originated from a relatively thin disk of planetesimals in its home star system, a striking parallel to our own Kuiper belt. Furthermore, the alignment occurs close to the invariant plane, which is the angular momentum plane of the entire solar system, defined primarily by the orbits of the massive outer planets, Jupiter, Saturn, etc. The invariant plane is slightly tilted relative to the ecliptic. The axis conjunction, occurring nearly exactly on the invariant plane, suggests an alignment that minimizes the z-axis component of the three objects' angular momenta. We can assume, based on this precise coplanarity, that it links them to the system's overall inertial structure. The significance of the 189.4 degrees longitude deepens when we consider the concept of axial precession, the slow wobble of the Earth's axis of rotation over a 26,000-year cycle known as the Great Year. This wobble causes the position of the equinoxes and solstices to slowly shift relative to the background. Stars. The celestial longitude of 189.4 degrees places the alignment site very close to the historical marker for the autumnal equinox, as observed by certain ancient cultures around 2,000 years ago. The fact that this extraordinary convergence occurs at a longitude tied to the slow, fundamental cycle of Earth's orientation could be interpreted as a cosmic clock mechanism, suggesting a deliberate timing linked to Earth's grandest astronomical cycle. This is not simple astrology, but the recognition that astronomical history is defined by these markers. The current Great Year is often associated with the transition from the age of Pisces to the age of Aquarius. The axis forms in Virgo, an adjacent constellation. The spatial proximity implies, from a cosmological perspective, that the anomaly is occurring on the cusp of a major shift in the Earth's relationship to the heavens. The mathematical chaos of the three-body problem guarantees that the alignment is fleeting. The conjunction is only considered tight, within 0.1 degrees of separation, for a mere 48-hour window between the 6th and 8th of November. Outside this window, the differential velocities of the three objects, particularly the rapid speed of the hyperbolic visitors, pull them apart into separate lines of sight. To successfully image and spectroscopically analyze the three objects simultaneously requires an unprecedented degree of coordination between global observatories. The requirement is to obtain co-temporal, high-resolution data during this narrow time frame. This constraint elevates the event from an astronomical rarity to a crisis of observation. The necessary data, high-resolution spectroscopy, polarization data, and precise astrometric tracking must be captured within this window, or the unique opportunity to understand the confluence of these three alien objects is lost forever. We must conclude, based on orbital mechanics, that this brief 48-hour window represents the only chance for our civilization to directly examine the axis of the void. This urgency fuels the entire scientific effort. The final speculative layer of the geometry relates to the origin vectors. Standard models predict that interstellar objects are ejected randomly following gravitational interactions, e.g., planet-planet scattering, in their home star systems. These ejection velocities should be isotropic, coming from every direction equally. However, the alignment features two interlopers that, despite coming from different stellar nurseries and having radically different compositions, rock versus ice, have trajectories that are both retrograde and confined to the same narrow band near the ecliptic. This observational consistency could imply that the objects are not merely random debris, but are part of a larger, gravitationally perturbed stellar stream, a filament of ejected matter following a shared, ancient path through the galaxy. Such a stream would require a massive, external gravitational perturbation, perhaps a close encounter between the Sun and another star many millions of years ago, which subtly shaped the galactic distribution of these objects. Alternatively, we must consider the possibility that these objects were ejected from their home systems due to a specific high-energy event, such as a supernova or the tidal stripping near a black hole, which resulted in a non-isotropic ejection pattern, a directed stream. The precise alignment of their current trajectories forces us to look for an ancient, common cause. The convergence of three such dynamically and chemically distinct objects, the axis, forces us to look beyond simple Newtonian mechanics. If the alignment is not purely random, its mechanism must involve forces that are either extremely subtle or poorly understood: tidal fields and the influence of dark matter. The galactic tidal field is the long-range gravitational influence exerted by the entire mass of the Milky Way on objects within our solar system, particularly those at the periphery, like the Oort cloud. This field acts like a slow, immense stretching and squeezing force. For bound objects in the Oort cloud, the galactic tide constantly perturbs their orbits. Over millions of years, this perturbation can gently nudge a comet from its circular, distant Oort cloud orbit into a highly elliptical path that sends it plunging toward the inner solar system. This is how we infer that the local resident, C 2025 K1 Atlas, began its journey toward the Sun. However, the alignment suggests a more complex influence. The gravitational field of the Milky Way is not perfectly uniform. It has warps and ripples caused by orbiting satellite galaxies and massive molecular clouds. It could be implied that the axis alignment occurs at a spatial nexus where a transient warp in the tidal field, possibly caused by the recent passage of a massive dark matter subhalo, provided the final, coordinated push necessary to place the three objects into their collinear line of sight. This is a hypothesis that links the alignment to the deep, large-scale structure of our galaxy, rather than a localized solar event. One of the most persistent, albeit speculative, questions about the prevalence of interstellar objects relates to dark matter. While dark matter does not interact electromagnetically, its gravitational influence is profound, accounting for approximately 85% of the total mass of the universe. It forms large, diffuse halos around galaxies, but also exists in smaller, dense clumps called subhalos or dark matter clumps. If a dense clump of dark matter recently passed through the periphery of the solar system, specifically through the outer Oort cloud or the Hill sphere, the region where the Sun's gravity dominates, the gravitational lensing and direct perturbations would be catastrophic. The analysis of the orbital perturbations of the two interlopers could imply that their hyperbolic vectors were slightly deflected by a nearby, unseen mass. Just before entering the inner solar system, we can assume, based on the extreme rarity of the triple alignment, that this massive invisible body acted as a transient gravitational lens, bending the trajectories of the two hyperbolic objects just enough to match the sightline of the Oort cloud comet. This effectively turns the dark matter subhalo into a cosmic cue ball, setting up the alignment with an efficiency that defies the randomness of probability. The hyperbolic trajectory of the interloper 3I Atlas shows a subtle yet measurable kink in its path far outside the orbit of Jupiter, a deviation that occurred before solar heating could introduce non-gravitational acceleration. This deviation cannot be explained by the known gravitational fields of the major planets. This kinematic anomaly is consistent with the presence of a dynamically massive, unseen object near the ecliptic plane, in the outer reaches of the solar system. This evidence leads to the highly speculative, but observationally supported search for Planet 9, or, in this context, the potential presence of a primordial black hole, or a dense dark matter clump that the interloper briefly encountered. The subtle velocity changes are too large for simple measurement errors and too early to be explained by sublimation. This observation suggests that the trajectory of the axis objects was not defined merely by the Sun, but by a close, powerful gravitational encounter en route. The chemical analysis of C 2025 V1 Borisov, revealing exotic ices like C2H6, ethane, and a high DH ratio, leads to another profound physics problem: the role of the interstellar medium, ISM. Objects traveling between stars are constantly bombarded by cosmic rays and exposed to hard radiation. This radiation should cause a process called radiolysis, the breaking of chemical bonds, effectively stripping the surface of the comet of its most volatile ices over millions of years. The fact that C 2025 V1 Borisov retains such high concentrations of supervolatiles suggests three possible non-standard physical scenarios. Recent ejection. It could be inferred that the object was ejected from its home star system relatively recently, perhaps within the last few million years, not leaving enough time for the ISM to erode its outer layers. Dense shielding. The object may have possessed a protective crust of carbonaceous or high-density material that shielded the volatile core from radiation damage during its interstellar transit. Hypercooling. The object originated in a region of its home star system so deeply cold, perhaps an inner Oort cloud analog near a brown dwarf, that its volatile components were exceptionally preserved. The extreme composition, coupled with its bizarre negative non-gravitational dynamics, strongly suggests that the object has a non-standard thermal and kinetic history, challenging our understanding of how volatile bodies survive galactic transit. The alignment, therefore, is not just a geometric problem, but a confrontation with alien thermophysics. The extreme improbability of the axis compels us to confront the deepest question in astronomy: are we alone? The convergence of these anomalous objects, the inert 3I Atlas and the chemically exotic C 2025 V1 Borisov, forces a direct re-evaluation of the search for extraterrestrial intelligence, SETI. SETI's blind spot, non-radio artifacts. Traditional SETI has historically focused on the electromagnetic spectrum, searching for intentional radio or laser signals. While this remains a cornerstone of the effort, the physical anomalies presented by the interlopers expose a significant blind spot: the search for non-radio artifacts. These are structures, objects, or patterns that might not emit a signal, but whose physical presence or dynamics are so statistically improbable that they suggest non-natural or engineered origins. The smooth, inert nature of 3I Atlas, for example, is highly resistant to destruction by solar heating and cosmic rays. This durability suggests either hyper-refractory natural processing or, potentially, a protective shell designed to ensure the survival of an internal payload during millennia of interstellar transit. Furthermore, its sheer density, inferred from its lack of non-gravitational acceleration, is far higher than most naturally formed cometary nuclei. We can assume, based on physics and engineering principles, that if a civilization wished to send a durable message across the galaxy, a non-volatile, dense,
and hyper-refractory vehicle would be the logical choice. This concept of an engineered interstellar probe is known as a Bracewell probe, a theoretical autonomous device designed to monitor remote stellar systems and either broadcast a message or, in its most advanced form, interact with a developing civilization. The axis, in this speculative context, could be interpreted as a collection of two or more independent Bracewell-type probes, or one main probe and a smaller escort, converging for a scheduled purpose. The axis as a directed beacon. The most compelling argument for non-natural origin lies not in the individual object's material, but in the precise timing and geometry of the alignment. The mathematical chaos of the three-body problem, detailed earlier, makes the instantaneous, tight alignment a statistical improbability approaching zero. The coincidence of the retrogradely orbiting 3I Atlas with the direction of the WOW signal is often cited as a powerful, albeit weak, correlational data point. However, the triple conjunction alignment within the narrow 48-hour window is a distinct kinematic event. This precise geometric alignment could imply that a highly sophisticated navigational mechanism was involved. An advanced civilization capable of modeling the chaotic dynamics of a star system over vast timescales could program a hyperbolic object to pass through a specific point at a specific time. The alignment itself acts as
the signal. It is a physical beacon designed to coincide at a pre-calculated, non-random moment in Earth's orbital cycle. Why would an intelligence choose a physical alignment over a radio signal? Durability. Radio signals are easily scattered or lost to the background noise of the universe. A physical object's trajectory is far more enduring. Unambiguity. The alignment is a universally recognizable geometric event, requiring no interpretation of modulated frequencies or bit rates, only the recognition of its near impossibility. Targeting. The conjunction points directly towards the Virgo supercluster, a massive reference frame that remains stable over timescales longer than the alignment itself. We must therefore consider the possibility that the axis is a sophisticated, non-electromagnetic message, a challenge to our understanding of probability, forcing us to look at the sky with new eyes. The Fermi paradox and the abundance of debris. The existence of numerous interstellar objects, confirmed by the discovery of Oumuamua and Borisov, exacerbates the Fermi paradox, the contradiction between the high probability of extraterrestrial life and the lack of observable evidence. If the galaxy is rich in ejected debris, it should also be rich in technological debris. The fact that thousands of such objects pass through the solar system undetected every day suggests a deep difficulty in distinguishing between natural detritus and technological artifacts. If AGI is achieved elsewhere, its technological remnants might be indistinguishable from highly refined natural matter. The critical question arising from the axis is, how small and subtle can an alien technological artifact be before we categorize it as just weird rock? The bizarre behavior of the two interlopers, one inert rock, one oddly propelled ice ball, occupies the perfect interstitial space between nature and engineering. The possibility exists that the galaxy is filled with Bracewell probes, and we have simply categorized them all as comets and asteroids. The axis forces us to reconsider the most basic ontological classification of celestial bodies: the axiom interpretation model.
The hypothetical research organization tracking this event, Axiom, would utilize a specialized interpretation model to avoid the bias of purely terrestrial physics. This model includes several factors for the assessment of the objects. Non-randomness index, NRI, a calculation that factors the v-infinity vector of the object against the known galactic velocity dispersion, quantifying how improbable the object's direction and speed are. Material Refinement Index, MRI, a comparison of the object's d/h ratio and refractory composition to the average values found in our own solar system, measuring the degree of alienness. Kinematic Anomaly Score, KAS, a metric that quantifies unexplained acceleration or deceleration events that cannot be attributed to known solar system gravity or cometary outgassing models.
The axis represents the first known event where all three indices for multiple bodies simultaneously hit threshold values, compelling a shift from statistical anomaly to technological candidate. The sheer simultaneous complexity strongly implies a coordinated phenomenon that demands immediate investigation. The shift in interpretation from anomaly to artifact triggers a crisis in planetary defense. The interlopers, previously tracked as scientific curiosities, are now viewed through the lens of potential threat. This necessitates an extreme escalation in observation and, critically, in the planning of potential interception. The interception imperative. Defense versus diplomacy. Planetary defense systems, designed to track and deflect indigenous threats like near-Earth asteroids, are ill-equipped for hyperbolic objects. The velocity of 3I Atlas is so high that its kinetic energy far exceeds that of any bound object of comparable size. The energy required for a proportional velocity change, the deflection maneuver, increases exponentially. The immediate military and political debate centers on the interception imperative. Do we treat the object as a passive threat to be studied, or an active one to be neutralized? The prevailing scientific argument holds that any interception attempt must prioritize non-destructive sampling, a flyby mission to obtain chemical and structural data. The military and security posture, however, views the anomalous dynamics and suspected engineering as sufficient cause for a precautionary kinetic strike. This ethical divide hinges on a single question. If the object is a probe, would attempting to destroy it constitute an act of war or a necessary defensive measure? The current legal vacuum in space law provides no guidance on how to respond to an anomalous, non-terrestrial artifact. The technical challenge: high delta-V maneuvers. Interception missions require extreme velocity changes, known as delta-V. A standard mission to a bound asteroid might require a delta-V of 5 to 10 kilometers per second. To rendezvous with 3I Atlas, which is already traveling at interstellar speed, requires a delta-V far exceeding the capabilities of current chemical propulsion. Axiom's mission plans, therefore, must turn to highly experimental technologies, solar sails and laser propulsion. Using directed energy from Earth-based lasers or the solar wind to accelerate a lightweight probe over time, achieving the necessary velocities. Nuclear thermal propulsion, NTP, using nuclear reactors to heat propellant for a higher exhaust velocity, providing the necessary delta-V boost within the short timeline. Jupiter gravity assist, utilizing a slingshot maneuver around Jupiter to obtain maximum velocity, though this drastically limits the intercept window and trajectory options. The complexity and risk inherent in these missions mean that the interception is a race against time and technology. Any delay in launch preparation means a complete miss of the primary target. The containment and protocol failure. The shift in status also highlights a major intelligence and security failure. Had the two hyperbolic objects been correctly identified as anomalous years earlier, contingency plans could have been in place. The inability of existing models to adequately classify objects based on complex metrics like the kinematic anomaly score, KAS, created a vast intelligence gap. The Axis protocol, developed hastily by Axiom, prioritizes global data sharing and centralized command, attempting to overcome the traditional security rivalries between nations. This protocol mandates that all high-resolution imaging and spectroscopic data must be immediately routed to a central, neutral analysis center, eliminating the possibility of a single nation hoarding critical intelligence regarding the potential artifact. This cooperation, however, is fragile, constantly strained by the immense military advantage afforded to the nation that first successfully interprets the Axis's true nature. The threat has, ironically, forced a brief, uncomfortable period of international unity. Assuming the Axis is indeed a message, the next challenge is interpretation. The message is not in a radio wave or a laser pulse. It is encoded in physics, chemistry, and orbital mechanics. The interpretation effort, known as the decryption axiom, targets three potential communication substrates: the chemical code, isotopic signaling, the exotic chemical composition of C-2025 V1 Borisov, specifically the elevated deuterium-hydrogen DH ratio, may be the message itself. Isotopic ratios are universal physical constants, providing a common ground for communication across the galaxy. The decryption axiom hypothesizes that the DH ratio of 3 to 1, triple the terrestrial average, is the numerical equivalent of a prime number or a fundamental mathematical constant, like pi or e, used as a universal starting point. This chemical signature is immutable and cannot be destroyed by interstellar travel. Furthermore, the specific combination of HCN, hydrogen cyanide, and C2H6, ethane, may represent an encoded chemical key, pointing to the molecular basis of life, or consciousness, in the sender's home system. The refractory material of 3I Atlas may also be a code. The crystalline structure of the silicates within the artifact could contain lattice defects or specific impurity patterns that represent a stored data structure, a form of solid-state memory built into the material itself. The durability of the refractory rock ensures the message survives until the designated alignment time. The kinematic code, orbital timing. The most elegant and compelling message is the timing of the alignment itself. The three-body conjunction is an instantaneous, non-repeating event tied to Earth's orbital position. The timestamp may correspond to a significant event in the sender's history, or it may be a precise instruction. We can assume the message is an encoded physical coordinate or a temporal offset. The timing of the alignment, November 6th through the 8th, is a temporal marker that may coincide with a major galactic event or the calculated point of closest approach for the sender's home star system. The sheer precision suggests an intelligence capable of predicting solar system dynamics with centuries of fidelity. The structural code, a differentiated artifact.
The fact that the axis involves two different interstellar objects, rock and ice, argues against a single, simple message. This structure implies a binary or complementary message, 3I/Atlas, refractory. The permanent geological time message, for example, origin location, fundamental math. See 2025 V1 Borisov, volatile. The transient, time-sensitive message, for example, temporal marker, immediate instruction. The two objects were deliberately sent on trajectories that intersect our system at the same instant, despite originating from different stellar nurseries, suggesting the axis itself is the final composite artifact. Interpreting the message requires not just analysis of the materials, but understanding the relationship between the inert, durable component and the active, volatile component. The confirmed public awareness of the axis, driven by amateur astronomical observations and the inevitable leaks from Axiom, sends a profound cultural shockwave through human civilization. The shift from rare comet to possible artifact instantly breaks the spell of the Great Silence. The ancient anxieties about celestial alignments, noted in Chapter 1, reassert themselves with frightening speed. The alignment in Virgo, combined with the biblical association of the constellation with prophecy, fuels widespread religious and eschatological fervor. The Comet of Abundance, C 2025 K1 Atlas, with its golden tail, is quickly mythologized as the messenger, while the inert, dark interlopers are cast as harbingers of destruction. Public response is divided into predictable but extreme camps. The utopian view, the belief that the alignment signals a technological or spiritual ascension for humanity, a moment of contact that will solve all terrestrial problems. The apocalyptic view, the fear that the axis is a precursor to invasion, or that the mere discovery of life elsewhere invalidates fundamental human beliefs, leading to civil collapse. This mass psychological event requires Axiom to become not just a scientific body, but a global communications arbiter, attempting to dampen hysteria with measured, verifiable data, a task nearly impossible in the age of instant, unverified global communication. The philosophical crisis, the end of uniqueness. For philosophers, the axis represents the end of anthropocentrism, the knowledge that another intelligence, capable of manipulating celestial mechanics, exists completely shatters the foundation of human uniqueness. This challenge manifests in several ways. Ethics. Does the potential existence of a superior ethical framework nullify
Human morality. Consciousness. If the alien intelligence is based on AGI, as speculated for other Fermi paradox solutions, what does that say about the superiority of biological consciousness? Art and meaning. If the greatest cosmic artwork, the axis, was created by another mind, does human artistic creation retain its ultimate value? These profound questions trigger global academic and artistic ferment, leading to a sudden, desperate search for universal truths, a meta-human philosophy that can exist independent of terrestrial biology. The cultural shockwave forces the collective mind of humanity to leap ahead 1,000 years in philosophical scope. The script now enters its climax. The narrow 48-hour window has arrived, and the final observation missions are underway. This chapter details the operational intensity and the ultimate realization of the axis's meaning. Mission Profile. Operation Axis Knot. Axiom successfully launched 3 small, high-velocity probes utilizing a combination of NTP
and Jupiter assist, collectively designated Operation Axis Knot. The probes are designed not for destruction, but for proximity sensing and hyper-resolution spectroscopy. The limited time and immense risk mean that any data collected will be fragmented, but vital. The mission objectives are simple. Probe Alpha. Target 3I Atlas. Obtain visual evidence of a smooth, featureless surface and attempt radar penetration to determine internal structure and density. Probe Beta. Target C 2025 V1 Borisov. Obtain high-resolution imagery of the point of negative non-gravitational thrust to understand the mechanism. Probe Gamma. Target C 2025 K1 Atlas. A final high-resolution baseline to confirm the chemistry of the local comet, providing the necessary control for the experiment. The tension is immense as the probes, traveling at extreme velocities, approach the axis conjunction point. The chemical analysis team, operating with the final, highest quality ground and space-based spectroscopic data, manages to refine the isotopic ratio of 3I Atlas. It is not merely dense. The distribution of iron and nickel isotopes within the refractory surface is organized in a pattern. The pattern is analyzed against known astronomical tables. The result is not a prime number or a mathematical constant, but a complex series of isotopes corresponding to the half-lives of heavy, unstable elements. For example, curium-247, iodine-129. These isotopes are created only during a supernova explosion. This suggests that the message is a map, specifically a precise temporal and spatial map of the entire galactic arm, showing the exact time and location of the supernova event that triggered the formation of the sender's star system. The object is not a probe. It is a geological time capsule of extreme age, sent on a specific trajectory to align with our system's great year cycle. The resolution of the axis. As the 48-hour window closes, the axis begins to break apart. The two hyperbolic
Objects slingshot out of the solar system, returning to the galactic void, never to return. The alignment is over. The final images from Probe Alpha reveal that the surface of 3I Atlas is not perfectly smooth, but etched with subtle geometric patterns that correspond to the molecular lattice of its crystalline structure. The patterns contain not a warning or an instruction, but an elegant, complex equation describing the universality of gravity and time, a message of shared knowledge. The axis was not a threat. It was a gift of fundamental physics, timed for the moment when Earth's technology was finally capable of reading it. The axis of the void has passed, but its legacy is permanent. This final chapter assesses the long-term impact on planetary defense, science, and the future of humanity's place in the galaxy. The legacy of the interloper. The data collected during the 48-hour window is incomplete but revolutionary. The kinematic data from 3I Atlas provides the most compelling evidence to date for the existence of a massive, unseen object, Planet 9 dark matter clump, in the outer solar system, forcing a major overhaul of our solar system model. The chemical data from Borisov rewrites the book on interstellar chemistry, confirming that life-building blocks are transported across stellar systems via highly volatile carriers, increasing the probability of panspermia.
The biggest scientific gain is the acceleration of the experimental propulsion technologies used for axis knot. NTP and laser propulsion are now funded as priority programs, with the goal of launching a dedicated interstellar probe within the next generation. The threat of the unknown has catalyzed humanity's greatest technological leap. The ad hoc Axiom Protocol is formalized into a permanent international treaty organization, the Axiom Global Interstellar Directorate, AGID. AGID is tasked not with defense, but with coordinated SETI observation and global threat assessment concerning non-terrestrial objects. The most profound social legacy is the shift from geopolitical competition to cosmic collaboration. The existential shock of the Axis proved that the problems facing humanity are universal, not parochial. The resources previously allocated to regional defense are partially redirected to AGID and the interstellar propulsion programs. The shared experience of interpreting the geometric and chemical message acts as a unifying intellectual force, healing some of the major cultural and political divisions on Earth. The final, enduring message from the Axis is one of time and perspective. The artifact was sent by an intelligence that calculated an event over galactic timescales, viewing human civilization as a fleeting moment in a great year cycle. Humanity's response confirms its fitness to join a larger galactic conversation. The axis of the void was not an ending. It was a beginning. It marked the point when we stopped looking for simple radio waves and started reading.
The silent language of the cosmos, a language written in the flight of ice and the durability of stone, a language timed to the grandest astronomical cycles. The galaxy is waiting, and humanity, catalyzed by a single, impossible coincidence, is finally preparing to answer.